You guys all know how much I love chocolate chip cookies. I love them. They're so good. All right. Anyways, so I've been building a single push button chocolate chip cookie vending machine, right? You saw the cookie dough cannon I made to extrude the cookie dough. Now we have the issue of how fast can you cook a chocolate chip cookie? That's a problem, right? You don't want to wait 10 minutes for your chocolate chip cookie. So we're going to combine all of the ovens together and see what we can make. Let's do it. Instead of make it go through the microwave and then into the conveyor oven, we're going to have them get married. Yay. So my current conveyor oven didn't have enough shielding, so I went to my favorite thrift store and found an air fryer that had a good solid metal enclosure and could easily hold the microwaves for us. Step one was getting all the plastic off so that we can modify the door for a screen and also add a screen to protect the heating coil so the microwaves wouldn't want to attenuate onto the coil. Here you can see it screwed into the top of the lid. All right, a word of warning on microwaves before we start opening one up. First off, don't open one up. If you don't know what you're doing, you're going to get yourself potentially killed. It is not worth it. But let's say you are skilled and you understand what you're doing. Some reminders for you so that you don't accidentally make a mistake. Microwaves work off of high voltage. You have a high voltage transformer right here that is charging up this capacitor. Now, you always want to make sure that it is discharged. You can do that with an insulated screwdriver or something and discharge it between those terminals. Now, it should always have a diode going to the frame. However, you don't ever want to guarantee that that diode is working, so always make sure you discharge the capacitor and make sure the microwave is unplugged before you start working on any microwave circuit. Just do not think that it's discharged and end up shocking yourself. It might kill you. Also, don't touch the stud on the magnetron where the microwaves are emitted. It's got all sorts of nasty chemicals. It's not good to touch either. Now, the old air fryer wasn't meant to hold in microwaves, so it didn't have a metal mesh screen in the window. Luckily, the old screen was about the same size as the window, so I just cut it to fit, screwed it into place so that it became grounded, and then just replaced it into the window and all was good. After that, it was time to make a hole for the magnetron. So I cut a hole that would fit the magnetron into it, and then mounted the old magnetron cavity from the old microwave onto the back of the new air fryer cavity. Some quick holes to mount some screws and screw it all together, and we are good to go. Finally, with it all mounted on there, it was time to mount the magnetron and then put in the splash shield. So I put it all back together using lots of copper tape to insulate it from any leaking microwaves, and look at that beautiful magnetron mounted on there. Plus, we were able to insulate the door as we needed, and we're also able to insulate the ceiling so that microwaves don't leak out into the upper heating element. Now, you might remember that I had ripped out all of the electronics from the microwave. So luckily, I just dug into my big box of automation components and was able to get all the pieces I needed to control the microwave. Wait, you don't have a big box of automation parts? Come on. Snip, snip, screw, screw, zap, zap. All right, so I've got the magnetron installed in here, and I tried to seal up all the gaps the best I could. Magnetron needs cooling, so we got this sweet cooling fan right here. That should still work. And then we've got our capacitor, high voltage capacitor, and I always made sure that the capacitor was discharged with a well-insulated screwdriver before working on anything. Never, and this could spark if it actually had power. So you always want to make sure that capacitor is discharged before you work on anything. In fact, I don't recommend working on microwave anything. Nobody should touch a microwave. Don't do what I'm doing. Okay, so power in. It goes into distribution here. Power supply for the oven. 24-volt power supply, 24-volt bus. 24-volt bus goes over to this switch to where it then hits this relay, and this relay on and off then goes through a fuse. Well, technically it's a 10-amp breaker, and then into this high-voltage transformer that turns the magnetron on. So we'll try it by itself first, and then we'll try it with the oven on and see whether or not it destroys it and burns it out. I did add in the oven shielding on the top to protect all the elements. So in theory, the convection circuit should be isolated from the magnetron, but we're gonna find out, hopefully not the hard way. So I'm not completely stupid. I do have this microwave radiation meter here. And so you turn it on and then you set it to 0, right about there. And we'll use that to determine whether or not it is leaking any radiation. It's got this little probe that keeps the tip of the sensor, or really it's an antenna, away from the microwave at a certain distance so it can check requirements. But we'll see. All right, Clark Griswold moment here. Okay. I've got airflow and no magnetron yet. It's working. Whoop, I hear a spark though. That's not good. All right, so I think I found one leak, and I can tell because when I turn on this meter, I put the probe in the back corner, right there. Oh, too much. So, I found out I've got a leak. So this microwave meter works. If you ever need one, buy a legit old one, as opposed to one that you don't know if it works or not. These old ones were built really well. So I'll save you the sad story, but it didn't work. I couldn't fix all the leakage, and I decided I needed to start over. All right, so what happened? Well, basically it all came down to the fact that air fryers aren't designed to shield radiation like a microwave is. It most likely was due to the fact that the door didn't have enough overlap, and that's because of the way microwaves work. Here, let me illustrate. Now, I don't want you all to get bored. Don't worry. We got cookies coming, infrared video images, and super fast chocolate chip cookie baking action. So make sure you subscribe. So to understand why my air fryer microwave didn't work, we have to understand how a microwave works. Well, a microwave is actually a bigger wavelength than you think. Microwave wavelengths are actually 4.8 inches long. That's huge, right? And so with that, you got to say, okay, well, shouldn't anything smaller than 4.8 inches be able to stop a microwave? Well, yes and no. So let's say you've got a half wavelength hole, so 2.5 inches, and you have microwave trying to go out of it. Well, it's going to come out a little bit, but it's actually going to attenuate and then only get out, let's say 2.5 inches. So now this is just a really rough idea. Now it could be less or more than that. I'm not an RF engineer, but in general, it's going to come out a tiny bit. And so if you think about it in terms of, here's your microwave door and there's this metal mesh screen. If these are 1 millimeter holes, then the microwave might only be coming out about 1 millimeter. And so there's usually a plastic screen blocking friendly Joe user here so that they don't get hurt by the microwave radiation that is seeping through those holes a tiny bit. And so the problem I ran into is that all the gaps on this air fryer didn't have enough overlap. So if you were to look at a regular microwave door like this one, usually a microwave will have a nice solid, maybe 1 inch overlap here, compared to the air fryer had maybe a 1/4 inch overlap. And just like with the 1 inch gap here and it not being able to protrude down this slot, here, when it's not as far for it to escape, it had a little bit easier time to show up on the meter. So no matter what I was going to do, I was never going to be able to get it to have the leakage amount that I wanted it to have. And so I needed to start over. So I went back to the thrift store and got a big boxy microwave, hooked up all the electronics back to it, and then pointed a heat gun into the chamber to heat things up. Something I've always wanted to know is how the microwaves that had these little fans that spun actually were driven, and it turns out it's actually just driven by the airflow coming through the magnetron and then through the top of the case would hit this and then just cause it to spin at a random speed based on however much friction it had. Kind of neat. And then the whole point of this is that it would cause the magnetron waves to scatter more evenly on the inside of the microwave. But as you can see from the plate that was in there, no matter what, you still ended up with a hot spot in the center. So it attempted to do pretty well, but not quite awesome. Okay, convection oven, take 3. So we're going to heat the interior of this thing up to 375, and then we're going to pulse the microwave and see how hot, or I guess how quick, we're going to cook a cookie. While the oven was heating up, it was time to look at it with the thermal camera. It was pretty interesting to see how hot everything was getting. The magnetron stayed a lot cooler than I thought it was going to overall, but the outside of the case, of course, ended up heating up to 375 because it's metal, so time to get some insulation on it. Each cookie I made was 18 grams. They turned out pretty good, but as I got faster than 2 minutes, I started to see burning. There had to be something I was missing. I relocated the heat gun to the top so that way it would just crisp the outside of the cookie. It made a big improvement in how it turned out. Then I thought I'd never do better than 2 minutes, and I decided to start video recording a cookie while it was baking, and boom, this was the improvement I needed. By enabling myself to watch the cookie as it started to heat up, I could actually activate and cycle the microwave faster than I ever thought possible. Basically, I was keeping the cookie on the edge of boiling, heating up the water molecules just enough to where they'd start to steam out, and then letting it cool for a fraction of a second, and then heating it again. By pulsing it rapidly, I was able to cook the cookie faster and faster and faster, until finally I hit my record time. After that, speed started improving rapidly. We hit a minute and 30 seconds, and then we hit a minute and 15 seconds. And that's about where it plateaued. The bottom of the cookies looked great, and even the centers looked awesome. Yum. We also got to eat a lot of awesome cookies. You know, for science. So as you can imagine, I ended up eating a lot of cookies, but I also learned a ton. Basically, you are trying to get the moisture out of the cookie as quick as you can so that it is more or less steaming it, but not burning it. Because if you drive that moisture out by just holding the button down in the microwave, then you're going to start to overheat and just burn the material that's there, which is why you can't regularly cook a cookie in the microwave normally. If you put it in there for 30 seconds, you're just going to get hot spots and it'll burn it. I had to actively pulse it very, 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 very quickly, and that allowed it to have enough of a cool down period in order to make the heat transfer even. So I thought I'd have more moisture lost in the cookie. So if a cookie started at 19 grams, when I was done baking it a minute and 15 seconds later, it actually was only at 18 grams. So I was only driving out about 1 gram of water out of the cookie, which was surprising. So that made me basically realize if you have 18 grams of cookie and it takes a minute 15, that's about 4 seconds per gram for the cookie. So I wanted to see if that scaled by doubling the size of the cookie, and it was pretty close. And it ended up being about 2 minutes and 50 seconds for a 36 gram cookie. And since we had the heat gun blowing down on top, you had the benefit of if you wanted it a little crispier or a little bit less crispy, you could actually adjust that heat gun so that you could get the cookie exactly how you want it. So overall, I'm super happy with this design in terms of having the microwave be the primary cooking method, and then now the heat gun to crisp the outside, and then I might add a heat plate on the bottom to allow it to heat the bottom of the cookie quicker, because that's usually where it gets undercooked the most, is that the bottom isn't warm enough. So The next one I'm going to do is kind of like a bell jar that's going to come down. It's going to heat up the cookie from the convection of the hot air blower, from the microwave penetrating into it and heating up the water molecules, and then the hot plate having heat transfer straight from the bottom. So all those things maybe will break 1 minute and 15 seconds. But as far as I know, this is the fastest baked chocolate chip cookie that's actually cooked correctly. So I'm pretty excited. I hope you guys will like and subscribe so that you can see the push button cookie machine when it's all done. And I'll catch you next time. Thanks.